Hello everyone. Spectrogram. Actually, we're gonna work on 4 stages. After these 4 stages, your clips will be ready to be fed to the neural net or convolutional neural net. Let us dive through these 4 stages. I will work on the same Python file handling audio files. Make sure that you are mounted to your drive and make sure also your libraries are all imported properly and run. Now we can add a new section and I will call it spectrogram. Actually, spectrogram is the end of the journey for preparing the audios. Spectrogram, Control MB. No need for other sections, programming sections, to be displayed, so I will hide unnecessary sections for the sake of connect to our clips. I want to connect to the train sorted, so I will connect to audio. Any help? No help? AI, can you help? Audio files, help. Thank you. Thank you. It's a glob, train sorted file. Check the name, the path. Train sorted, yes. Control Enter. So Control MB. Now let we said we are in stage 1 because we said there's 4 stages. I will load audio using Librosa, of course. Any help? So Librosa dot load. Thank you. I will load like clip number 200, any clip you can load, and as usual, normally we get 2 values from the Librosa.load, the audio itself, comma, the SR equal, Control Enter. So now it's loaded properly. Let's play. Before play, this audio is a generic name. I will change to more scientific name. This raw audio actually have a scientific name, which is time_domain_audio. This is the correct scientific name of this audio. Control MB, play the audio, optional. We are still in stage 1. Play. Thank you. Time domain audio, yes, play. Cool. So Control MB, shape and the plot. So I will check the shape. We're still in phase 1. Shape. Any help? Thank you. AI. One dimension. One dimension array is non-informative. What kind of information you can get from one dimension array? Control MB. Any help for plot? Thank you. Make sure that it's time domain audio. Yeah, the original. Control Enter. Actually, this is the shape of the amplitude here actually only represent the loudness of the audio. So there is no information can be used for the neural net to extract. Only amplitude 0 is silent. More amplitude, that means there is a loudness in the audio. So we have to change the domain from time domain to frequency domain. So I will move to stage 2. Stage 2. I will use something called Fourier. Any help? Okay. I will do it manually actually, no help. So Librosa dot short time, yes. Actually, the Fourier will convert from time domain, which is not informative, يعني from time domain to frequency frequency domain. Frequency domain is more informative. It's two-dimension, more informative. So this is why we are converting from time domain, the original audio, to the frequency domain. So also I will give it a reasonable name. No more like time domain from now on. So it will be frequency domain audio. Control enter. Sorry, equal. So the new name of the audio will be frequency, okay, domain audio, okay. Control enter. Done, converted. Again, shape and plot. We are in stage 2, Control MB. Check the shape. Any help from AI? Please. Frequency domain.shape, thank you. Two dimension, not one dimension. Cool. So this is one of the benefit for the frequency domain. Thank you, Fourier. Thank you, Librosa. Plot, Control MB. Any help? Okay, but I will do some changes here. I will not apply the Librosa amplitude to disable. I will just go for numpy.abs. That's it. No numpy, so import numpy as MP. I will plot actually the frequency, make sure, Control enter. More information can be getting from this kind of. So now we finalize stage 2. Moving to stage 3, Control MB, and now we're gonna work on stage 3. Actually, stage 3, we can call it the spectrogram. Spectrogram. Any help? I don't want this kind of, so I will do it in myself actually. I will go, or maybe we can go for do it in myself. So I will say the new shape, not shape, the new name of the audio will not be frequency domain. I will call it spectrogram audio. So spectrogram underscore audio equal. Here I will gonna use not actually there is more than one type of spectrogram. One of them is mel spectrogram. I don't want to use this. I will use something called librosa.amplitude to dB. Okay, so it's librosa actually dot help. Yes, this is what I am looking for. Actually, we will convert our frequency domain to something to decibel. So this is why we are called it spectrogram. Control enter. So the new or the final destination of the journey will be spectrogram. Again, shape and plot. Control MB. Any shape, help for shape, please. Spectrogram.shape. Thank you, AI. No need all this time. Done. Still two dimension. Cool. And we are actually in the finals, not final stage. We are in the destination of spectrogram. Plot, please. Any help? Yes, yes, I will plot the spectrogram audio. Control enter. Thank you, Librosa. Actually, this is the final destination of our audio. Okay, look at the shape. It is more informative. The neural net that we're gonna use shortly is able to extract some features from this kind of shape or plot. Not the original plot as you see here. It cannot be extracted any features. The final stage actually, Control MB, stage 4. So stage 4. I just want to check the shape again. Help, thank you, AI. Our destination is 2-dimension. Actually, 2-dimension is not suitable for the neural net. Neural net need a 3-dimension array to be as an input to the neural net. So Control MB, I will expand dimension. How can we do that? Thank you, but actually not in NumPy. I will expand dimension using TensorFlow, not NumPy. Okay, so I need to import the TensorFlow. So import TensorFlow. Thank you, AI. AI is responding. So TensorFlow. Another thing, if you look at our shape, this is axis 0, axis 1. I want to insert the new dimension as the last axis, which is index 0, index 1. So it will be index 2, not in the index of minus 1. So here I will change to 2. Don't forget it is spectrogram, control enter. Have been changed from 2 dimension to 3 dimension. Check the shape again. Shape, yes, control enter. 3D, the end of the journey. Now we are ready to move to the neural net. What I am doing, all these 4 stages actually need to be applied into all the clips inside the train sorted folder. So that means there is a for loop including these 4 stages. See you next video.